Hi, in this video we are going to implement a depth first search together, so let's get started. I'm going to create a class called vertex. It is going to represent the vertices in our graph we want to traverse. So here I'm going to have a private string name. It's going to represent the name of the vertex. We are going to use strings such as A, B, C, and D as we have seen in the theoretical video. Of course, first of all, I'm going to create a Boolean flag whether we have visited this node or not. I'm going to create a list of vertices, and it is going to represent the neighbor or adjacencies list. These are just, we store references to the neighbors, and of course I'm importing java.util.list. And usually we will have the predecessor. It is the neighbor from where we are going to the given vertex. So the predecessor is the previous vertex. I think that's all we need. So in the constructor, I'm going to give a name. That name is equal to name. I'm going to have a method public void add neighbor, and it's going to be a vertex, of course. That adjacencies list that add the vertex, and of course, in order to avoid null pointer exception, I'm going to instantiate with an array list. This adjacencies list is an array list. Okay, and I'm going to use Eclipse to generate the getters and setter for us. So get adjacencies list, get the predecessor, and check whether it's visited or not. Okay, so that's all. Oh, of course, I'm going to override the toString method. Return that name. Okay, so that's all about our vertex class. Then I'm going to create the application from where we are going to run our algorithm, and of course I'm going to have a class called DFS, stands for depth first search. And in order to implement depth first search, we are going to need the stack data structure. If we want to implement the breadth first search, we have seen that we have to use a queue data structure. Here we have to use a stack. Okay, so I'm going to create a private stack, and of course I'm going to store vertices. Then in the DFS constructor, I'm going to instantiate this stack. No, this stack. Okay. And of course I'm going to I will have the public void DFS with the vertex root. So it is going to give us the depth first search and going to show us how to traverse our graph. So first of all, I'm going to add, it's very similar to breadth first search, but here we don't use a queue, we use a stack. So first of all, I'm going to add the root. Then I'm going to set the root to be visited, so set visited the root, true, yes. And I'm going to run our algorithm as far our stack is not empty. I'm just going to pop, so vertex actual vertex is equal to stack.pop. With the help of this pop, we are going to return an item from the stack. Then I'm going to system out printer and the actual vertex plus some spacing, and it just system out print. And I'm going to iterate through the neighbors, so the actual vertex that get adjacencies list, and check whether this vertex has been visited or not. And if it hasn't been visited yet, then I'm going to visit it. So just set it to visited, set visited true. And maybe sometimes it's in the shortest path algorithm, it's going to be important to set the predecessor to be the actual vertex. Here it doesn't matter, but if I have already implemented it, I mean I have created it, this variable, then I'm going to use it. So we set the predecessor, so we know that the previous vertex was the actual vertex for the V, but it's pretty straightforward, so we wouldn't need it. And I'm just going to push it to the stack, the V. And that's all about it. Our algorithm is going to run until this stack is not empty. We are going to pop our last item. In the first iteration is going to be the root. We iterate through its neighbors, and if we haven't visited the neighbors, we are going to push it to the stack. Of course, we just set it visited in order to avoid not to visit it again. So that's all about. I'm going to create a tree-like structure. So vertex 0, vertex A, new vertex. I'm going to create, for example, 5 with B, C, D, E. It's going to be a binary search tree, A, B, C, D, and E. So the vertex A, set neighbors or add neighbor, the vertex B, and I'm going to add the vertex C, then the vertex, for example, vertex B dot set add neighbors D and E, for example. So unlike breadth first search, we do not go layer by layer. The depth first search goes as deep into the tree as possible. DFS and the root will be the vertex A. A, C, B, E, D. And because the A, B, C and the C has the children E, that's why this will be the order of or depth first search. If it would be breadth first search, we would definitely get A, then B, C, then D, E. So it is working fine because it goes as deep into the tree as possible, and because A have just a single left child C, it is go from A, then C, and then it's going to visit the right subtree, which is B, E, D. So it is maybe not so straightforward in small examples like this, but if you want, you can play around with it. So that's all about how to implement depth first search with the stack data structures. Thanks for watching.